In this video, we're going to review right triangle trigonometry. Trigonometry is the study of the relationships among the side and angle measures in triangles. When you were taught right triangle trigonometry in geometry, you focused in on the side and angle measurements of your right triangles. What you did was you created a right triangle and you had an angle measure, one of the two acute angles. We're going to call this acute angle here theta. And then using that angle as your reference, you would describe one of the legs as the opposite leg. That would be the side opposite the angle. One of your legs as the adjacent leg. That's the one attached to the angle. And then we all know that the side length opposite the right angle is known as the hypotenuse. So the trigonometric ratios compare the lengths of two sides with respect to that acute angle, which again we're calling theta, in that right triangle. You worked with the three basic trig functions, sine, cosine, and tangent when you worked with these in your geometry classes. And if you remember, sine is the ratio that compares the opposite side to the hypotenuse and creates that ratio. Cosine of the angle theta would compare the adjacent leg to the hypotenuse. And then the tangent of theta would compare the opposite side to the adjacent side. You may remember your teachers giving you a special mnemonic, SOHCAHTOA, to help you remember those three ratios, where sine is the opposite over the hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. With these three trig ratios, we can then solve for any missing side or angle measure in the triangle. In this video, we're going to focus only on finding side lengths. When you want to use a trig function to find a side length, what you're going to do is you're going to start by looking at your triangle and identifying the angle that's acute and given to you. And then you're going to look to see if you have the opposite, adjacent, and or hypotenuse given to you. Once you identify your pieces, then you can go ahead and write the appropriate trig function for that. We also want to make sure that when we're using a calculator that it is in degree mode so that we get the correct answers for these problems, since all of our angles in our right triangles will be measured in degrees here. So in this first example, I have the 18-degree angle marked right here. That's my acute angle. The side length of 25 is opposite, and the side length marked x is opposite the 90-degree angle, so that's my hypotenuse. So when I have the opposite and the hypotenuse, that's when I want to use my sine ratio. So we're going to say sine, we're going to abbreviate that SIN, of our angle, 18 degrees, is equal to the ratio opposite over hypotenuse. We're going to put that side length of 25 for the opposite over that side length of x for the hypotenuse. Our goal now is to solve for x. So since I want to solve for x, I want to get the x by itself, so I want to get rid of it from the bottom of that fraction. So I'm going to multiply both sides by x to clear the fraction there. And that's going to leave me x times sine of 18 degrees is equal to 25. And then to get x further by itself, I'm going to divide both sides by sine of 18 degrees. And again, I have my graphing calculator, so I'm going to go ahead and use that. I'm going to make sure that my mode is in degree, so I can see the black boxes right there on degree. To find x, I want to do 25 divided by sine of 18. And I'll press enter, and my answer is 80.9016, blah, blah, blah. They want us to round to the nearest tenth, so I'm going to make it 80.9. So I'm going to say x is about 80.9 because it wasn't exactly that. And we don't have any units for our side length, so we're just going to leave it as 80.9. Let's work through two more quick examples. In this one here, my acute angle is 64 degrees. The side length of 3 is attached leg to that angle, so that's my adjacent side. The x is again opposite the 90, that's my hypotenuse. Adjacent and hypotenuse is my cosine, so I'm going to put cosine of 64 degrees equals the adjacent leg of 3 over the hypotenuse of x. Once again, my x is in the denominator. I'm going to multiply both sides by x. That gives me x cosine of 64 degrees equals 3. I'm going to divide both sides by cosine of 64. And again, to get my value for x, I'm just going to go back to my calculator. 3 divided by cosine of 64. Press enter. Again, I get a screen full of numbers. We want to round to the nearest tenth, so we're going to go 6.8. All right, we're going to end the video by doing one more example. In this case right here, I have the acute angle of 75 degrees. The x is my opposite leg. The 21 is my adjacent leg. They're both legs because they're both forming that right angle. Opposite and adjacent is my tangent ratio. So I'm going to say tan of 75 degrees. My opposite leg was x. My adjacent leg was 21. You're going to notice in this problem, my denominator was the number 21. So I'm going to multiply both sides by 21 this time to clear that fraction. So 21 tangent of 75 degrees is equal to x. I'm going to go ahead and use my calculator. 21 tangent of 75. And this time I get 78.373, blah, blah, blah. Since I want to round to the nearest tenth and the number after the 3 is 5 or higher, it's 7, we're going to round that up to 78.4. So that's a quick review of our SOHCAHTOA and how we can find the missing side lengths in a right triangle using sine, cosine, or tangent ratios.